right. Good morning to everybody. Let me see. Oh, my audio says it's muted. Oh, no, we're not muted. We're good. Okay, how are you guys doing? Everybody okay? I hope. Okay, now the chair sent me an email to not me, everybody in the department, an email to remind folks that let's see. I think I sent you guys that announcement, right? That the drop deadline is when? May 7th. So that's, the chair sent that to remind people. Remind students of the drop deadline, May 7th. So I sent you guys a message there last night about it. So if you, let's say you're not participating, because that happens. People don't show and they forget they're in the class. And then reality hits and they go, oh my God, that's right. I have that statistics class. Oh, shoot, I'm supposed to graduate. I'm like, wow. Don't show, don't do homework, don't turn in your extra credit, don't even do your exams. And, you guys know that story. Anyway, so I sent that announcement to folks yesterday to all my classes. And hopefully they're, you guys, I don't know. I don't know what to say. I'm just saying this is just a reminder. May 7th is the deadline. So that's all. Okay, you guys okay with that? So I sent that out yesterday. All righty. So if I take a look at what's going on, we're in the last leg of the course. And you go, okay, what's in the last leg of the course? Well, we got a few topics. And we got like estimation. We've been working with estimation, haven't we? Right? All right. We've been working with estimation. So this was the last estimation work that we did. I'm going to get rid of this here. Although, what I'm going to say to you guys is the problems we did last time on estimation, where you have the sample proportion plus the error, sample proportion minus the margin of error, that's mostly comes from what society expects you should be able to understand the meaning of. Okay, those kind of things. We went over that. Now, I'm going to give you the real life statistics version. So you go, what do you mean? Yeah. I'm going to give you the version now that a statistics student is supposed to be taking. Not somebody who hasn't taken statistics. Are you guys ready for it? It's not too bad. It's pretty simple. It's not too bad. There's some language, but let me do this here. Let's think about this. What kind of things are you guys interested in? Oh, you know what movie I seen this weekend, ladies and gentlemen? Kind of scary. Nefarious. Anybody know that movie's not Nefarious? Pretty spooky movie. Anyway. So statistics is supposed to be about real life stuff, right? So I'm going to give you guys a real life example. Okay? Because sometimes people say, those math people, they only talk about widgets. That's not true. We don't talk about widgets. So let's ask you guys this question here. I'm going to say this. It doesn't matter to me what your faith is. I'm not asking that. I'm going to say this to you guys. This is kind of how this really works. A sample, if I said to you guys, does anybody here have faith? It doesn't even matter what the faith is, what religion it is. Doesn't matter. Nobody's asking you to be a part of a particular religion. But any religion, whatever it is. Does anybody have any faith in any religion? Raise your hands high and proud, right? So if you raise your hand high and proud in any faith, it doesn't matter. Those are thought of as successes. You guys know what I mean? Those are successes. Doesn't mean that those are just yes votes. That's all. Out of the total. So you may read something that says this. It's going to say a sample of 180 college students, so you guys know, reveal that, I don't know, 95 have faith in some religion. Doesn't matter what it is. Okay? That's it. I just want to kind of remark and go into this statement here, because you're gonna read that statement. Okay, we got to really give you guys some details. What do you think they're saying? First of all, this is information that's coming from a what? From a sample. Is that true? So how do you know it's coming from a sample? Because it says what? Sample. Good. You guys see what I'm saying? Okay. And a sample of what? What does that say? Well, what does 180 represent? You see what I mean? I mean, language and process. What does that 180 represent? It's a sample size. That's N. Is that true? Okay, because they're saying a sample of 180 college students. That's your sample size. What do they reveal? What are they saying, ladies and gentlemen? What are they saying? That 95, that's a number. That 95 have faith in some religion. So here's what I want to say to you guys, okay? The definition of a sample proportion if you guys remember, I gave that to you guys the other day. That's X over N. What does X measure? X is called the number of what? Successes. You're counting successes. N is the sample size. Okay? So what they did is they gave you sample information. Does that make any sense? All right, so let's see what this is then. The sample proportion is going to be, ladies and gentlemen, 95 out of what? 180. $95 out of what? 180. Are you guys okay with that? So if I said to you guys, go over to the TI, let's compute the sample proportion. So 95 divided by 180, what do you guys get as a decimal here, right? Go to the nearest thousandths. What does this represent for you guys? 0. What? 528? Is that 528 to the nearest thousandths, ladies and gentlemen? I think so. So what they're giving you is a sample proportion, okay? And that is really 52.8%. Is that right? So I really want to emphasize this information here for you guys. Because in the past, if you look at your other examples, what did they do? They gave you the what? Sample proportion already. It was already computed. Is that true? So they compute it for the public, and sometimes they make those poor college students have to compute it themselves. They're going to expect that you guys know how to compute a sample proportion if you're a college student. So you go, oh, okay, is that a sample proportion? Yeah. So by this sample information, all they're saying is about 52.8% of college students have some sort of faith in any religion. It doesn't have to be, a particular religion, any faith. All right, you guys okay with that? What do you guys think? Easy peasy lemon squeezy? So this is the meaning of it. So very often, like I said, students read this and they don't even know what it means. And you have to go through it. You go, okay, this is a sample. And what happens? Yeah, they give you what? 180 college students reveal that 95 have faith in some religion. That's what it means. So, what's that? No, see, this is a good question. You have a very good question. Very good question. If they meant that it was 95%, what would they say? 95%. Yes, like in the last examples, they meant that this was what? 65%. So this is why I went through that exercise and asked you guys to raise your hand, right? Okay? That the definition of a sample proportion right in here has that value of X. What does X represent? Number of successes. What does N represent? It's the sample size. So we take the number of successes divided by the sample size, and that gives you, that information. So this is a very important piece to discuss with people. Don't think of having faith as a success. I mean, I personally feel it is, but it's not about that. It's not about that. Your successes could be anything you want. It depends on the question. So I just want you guys to give you, this is partly how a real question would look. It's kind of like, again, if I give you guys another example to talk about, or another note, right? Let's call this a note. Again, this is about college students. And I could even give you another illustration of what I'm saying. And again, I have to think of things that maybe are relevant to college students, because again, this what you're looking at is relevancy. I mean, I can talk about widgets. I can talk about fast food orders. Maybe you guys care about that. Okay, maybe you guys care about fast food orders. I don't know. You know what I hate? You ever order from Uber Eats? Do they ever cancel your order? I hate that. And Uber Eats is expensive. It should have been a sign. You should have said, forget it. Don't even bother anymore. Because Uber Eats, they're expensive. It's like, really? Jeez, I'm going to get in my car. But sometimes I don't want to lose my parking. You know what I mean? Huh? Just go yourself. Huh? Then the neighbors will steal my cones. They'll steal my cones and they'll park in my parking. Put police cones? Judge cones? Don't touch my cones? I don't know. You got to be careful these days. How about this? A survey of 250 residents reveal that 175 will not touch your parking cones. Okay? We're going to have to read this and make sense of what this means. We're going to compute the sample proportion. Okay? Now you say, but Mr. Judge, you didn't say sample this time. What did you say? Survey. Well, a survey comes from a what? Sample. So I want you guys to know that. Sometimes they say survey, sometimes they say sample. Now, when they say of 250, what does that mean? What does the 250 represent? Sample size. You guys good with that? All right, pretty good. No big deal. Now, what do they say? Reveal that what? 175 will what? Will not touch your parking cones. What does the 175 represent? Number of successes. What do they count as a success? Not touching cones, your parking cones. That's what they count as a success. It's going to be what's in the question or in the phrase there. That's all. So if you're going to compute a sample proportion, what's the definition? Do you guys know? What's the definition? It's the number of successes divided by the sample size. So what's that going to be? 175 out of what? 250. You guys okay with that? So what does that give you? Let's go to the TI. We'll go to the nearest thousands again. Let me scroll out. 175 divided by what? 250. What's that going to be? Oh, that's not even approximate. That's what? What does it mean if it's 0.7? Yeah, that just means 70%. Is that right? Okay, you guys okay with that? So this really, the meaning of this, the decimal representation is 0.7. That means 70%. Move the decimal 2 spaces to the right, and that's your percentage. Is that true? 70%, ladies and gentlemen. So what this is saying is that, I guess what? 70% of what? Residents will not touch your parking cones. All right. What else do you guys care about? This is just another note. A survey of teenagers. Oops, I forgot. A survey of what? 500 teenagers. Okay. Reveal that what? What do these 500 teenagers reveal? Reveal that, 322 own a Sony PlayStation. Let's just talk about this. What does this mean? What does that mean? Well, what does the phrase survey mean? A survey is a what? Isn't that a sample? What does the 500 represent? Sample size. Good. So they're saying, this is a sample of 500. That's a sample size. What does 322 represent? That's the successes. That's not a percent, is it? That's the number of people that said, I own a Sony what? PlayStation. So a success is owning a Sony PlayStation. Don't tell me, no, Mr. Judge, that's not a success. Xbox is. Well, that's not the point. It's the success is always in the what? Question. You guys okay with that? This is a survey. Okay. What's the sample proportion, ladies and gentlemen? What's that going to be? 322 out of 500. What if we approximate that to the nearest thousands? What do you get? 322 divided by 500. And what happens? This is going to be what? This is already to the thousands. What does that equal? 0.6 what? 44. What does that mean? That's 64%. Is that true? So this survey is saying 64% of teenagers reveal that they own a Sony what? PlayStation. What do you guys think? What do you guys think? Is that okay? Anyway. What other kind of example could I give you guys? Because we're doing kind of the S portion of the class. You guys know what I mean? The S portion, supplement. What do you guys think? Is that easy? They don't always give you a nice what? Percent. How do you know when they give you a percent? They'll say percent. They'll have the percent symbol. Exactly. You guys know? You guys see what I'm saying? Not too bad. All right. What else? What other kind of examples do you guys care about? You think? What do you think? What other examples do you guys care about? Since we're on the topic. Oh no. Haven't had my coffee in me. What should we say? Huh? Age? Paychecks? Oh, you're gonna depress me now. Don't make me depressed. I don't want to think of that. You guys care about that stuff? Pairs of shoes? Huh. Let's think about this. It's how you phrase it. How about, has anybody ever eaten at Teddy's Tacos? Do you like them? Very, very overpriced. They're expensive. That's the first thing I thought. And you get them free? Really? You know Teddy? Oh, you know someone who works there. Okay. All right. I won't say anything. Maybe you should give them my recommendation. I think they need some salt. Personally. I wasn't either. I thought I would be. I thought I would be a fan. I tried them, and I'm like, what? Need some salt on these things. Jeez, really? Not only that, you need some chili on that, too. Anyway. Yeah, whatever. But they're kind of a big deal. You guys know what I mean? I was going to make my own. Compete with Teddy. But that's hard work, ladies and gentlemen. Getting in the restaurant business, being consistent. Hard work. You guys don't like it? How about this? Where's the best tacos? What do you guys think? Actually, there's a place I go to that I like. Down the street. Oh, is it a truck you go to? You know where I get my tacos? You might even see me. These aren't too bad. They're pretty good. Right, okay. They're not always perfect though, but you know where you go? God. Go on Atlantic. You know where Pep Boys is? Right there. That corner. That's a good. They have some good tacos there. They're pretty good. You like them? They're good there, right? Exactly. Yeah. But be careful. I get the hot sauce. That orange one. I love that sauce. Yeah, it's habanero. That has to be. But you can't put a lot of it. Don't put a lot of that stuff on it though, because then you make your taco you can't eat it, and you're like, you just messed up your taco because you're like, what? You put all that habanero sauce on it. Now you can't even eat it. You're like, oh. Hmm. So it's even further, huh? It's better than King Taco. That's all I know. If you go try King Taco, you're gonna taste the difference, and you're like, what? Was it you guys that told me that King Taco's all frozen? Some class told me that everything. Somebody worked there at King Taco, and they said everything is frozen. Everything. I go, really? It's frozen. You can taste it now. And then I went back to King Taco because I get a all meat carne asada burrito. And then I had it, and I'm like, ooh. It's like, what? Oh, yeah. Olive Garden's all frozen? Yeah. Well, again, consistency. Yeah. Interesting. All right, let's give a taco kind of a survey. Give a taco survey. A survey of 250 college students reveal that 126 prefer King Taco. Right? So this again is information that comes from a what? Sample. This is important. This is important to be able to do. What does the 250 mean? Survey of what? 250. That's the what? That's the sample size. What do they reveal? What are they saying? 126 what? Prefer King Taco. So what is a success? Preferring King Taco. They're counting people who prefer King Taco. I'm not in there. But 126 college students are. You guys know what I mean? So it's the people that raise their hand and say, yes, I prefer King Taco. Some people do. So it's successes divided by the sample size. You guys remember? This is the definition. X over N. So we're going to get the sample proportion, okay, because, we want to see what it is. 126 divided by what? 250. And that's going to be what? That equals what? 0.504. %50.4%. So 50.4% of college students prefer King Taco. What do you guys think? Is that easy peasy lemon squeezy? All right. Now, does anybody here does not like tacos? There has to be somebody. It's okay if you don't. You want to know what I like putting on my tacos? It's a finger food. Tacos are finger food, by the way. And they come from Spain, in case you didn't know. I think they come from Spain. If you look in the history of a taco, You know what I put on tacos? I like putting pickled red onion on them. You guys know that? Pickled red onion? Anybody do the same? Anybody know what I'm talking about? Anybody pickle their own onions at home? Pickle red? Yeah, you put pickled red onions. No, you guys don't know about that? Huh? So yeah, some places offer it. It's kind of it's an interesting thing. If you go to the Yucatan and you order a taco, I hear this, every place around the Yucatan area, they have pickled red onions. You put on things. Pickled red onion. You guys don't know about that? Go hang out in the Yucatan and you go to a restaurant and you have a table there. Oh, pickled red onions. Put on your food. Pretty good. Pickled red onion. You guys don't know? I'll Google a picture. Had to show my wife. She didn't believe me. She's like, what are you going to do with those red things in the refrigerator? Don't touch that stuff. It's my pickled red onions. It's like, what do you put on it? I go, put it on your burger, you put it on your hot dog, put it on your tacos. She goes, no, you don't. Because she likes to argue with me about everything. You know? If I say up, she says left. If I say down, she says right. That's her way of interacting, always saying the opposite. So you go put it on your taco. You're gonna love it. Because I don't put pickled red onion on my taco. Oh, you should. I had to show her a picture of tacos, and guess what? They all had pickled red onion on it. So see, it's not just me. The world does it. Go to the Yucatan. You can see it at your table, pickled red onion. You guys don't. I can't believe you guys don't know that. No, you haven't seen that? I'll have to show you guys a picture too. You ain't gonna believe me. You see, you have to give students real life questions in statistics. There we go. Oh, you guys can, let's share with everybody at home. What do you guys see? You see some pickled red onions on some tacos, ladies and gentlemen? Told you. It's not just me. That's the way you do it. If you haven't had it, you guys don't know what you're missing. Look at that. I want to get this picture. What's going on? Mexican pickled onions with lime juice. There you go. See, my wife's family is from Mexico. She was born in the United States, but her mom and dad came when they were 18. So I told her, if you go all over the Yucatan, you're gonna find that in your table. Ah, whatever. I can't. I hate these pop-ups. They're trying to sell me something. Just want to see about some nice pickled red onions. Jesus, really? So yeah, I got a jar in my refrigerator, just so you guys know. Toss in the habanero. Supposedly, if you toss in jalapenos and habaneros, that's also pretty darn good. Look at that. You guys want to eat that? You guys want to put that in your taco? No? Some people don't. Some people won't put anything. They don't put anything. That's like my wife. She doesn't put anything on it. Only lemon and salt. She's weird. Only lemon and salt. I made her spaghetti. You know what she told me? She didn't want any sauce. So, what? Who eats spaghetti without salt? What? I thought she was joking. I thought she was, again, being opposite. Yeah, I'll have some spaghetti. Just don't give me any sauce. Stop being, really. She was actually serious. Anyway, just want to throw that out there, you guys. Call Teddy and tell Teddy, hey, put some of this in your red taco. It's already red. Add red on red. You guys know what I mean? I can improve Teddy's tacos like that overnight. I guess I'm hungry. That's why I'm talking about it. I know I'm hungry because I'm talking about it. It's like your examples are Mr. Judge. Yes, they're realistic because of the fact that, yeah, there's all good examples, by the way. All these are good because this is more real life. And maybe if you guys see more real life things, then you care about it. Then when you see other things, they're also real life too. But, they start talking about widgets and defective phones and everything like that. You know what I mean? Then you can say, because here's kind of it's a manufacturing question, and maybe in sort of, business manufacturing, they can say, here's another note. A sample of 100 iPhones reveal that 8 are defective. This is another kind of setting. It may not be for you. You go, it's not about tacos. It's not about, what is it, Ghosts or Faith or a Sony PlayStation. It's our sleep time. But, this is how it works as well in that environment. So you can talk about a sample of 100 phones. So you say, what are they doing? They're going to a bin maybe of 100 phones, and what do they find? 8 or what? Defective. What does that mean? What's the sample proportion? Well, they didn't tell that to you. So now you got to say what? 8 over 100, that's the successes. You go, a success is being defective. A success is whatever's in the question. So this is like the defective rate for iPhones. Believe it or not, everything could be, any item that's manufactured can be defective. Jeez, have you ever bought something that was defective? You guys know? Isn't that kind of horrible? I don't like that. So you can buy something. It'll be 8 divided by what? 100. What is this? 0.08. You guys okay with that one? So what does that mean? That means there's an 8%, 8% of the iPhones were defective. 8%. All right, you guys okay with that? 8% are defective. What do you guys think? Not too bad. You guys see what I'm saying? Now, I'm going to transition. I'm going to start talking about margin of error. See, ladies and gentlemen, this topic is easy. You just have to read through things and pick out the information to plug it in your calculator. And it's meaningful because these are called point estimates. We're going to do interval estimates. Now, what I have to share with you guys is this. Let's pick a setting that you guys care about. I don't know. What do you care about? Do you care about PlayStation? You care about faith? Some religion? You guys care about parking cones? I don't know. Tacos? iPhones? What do you guys care about? Don't tell me paychecks. You're going to depress me. Oh, man, there's nothing more depressing than that. What's that? Pineapple on pizza? Oh, don't get me there. I'm going to run out of here and go get something to eat. I'm going to go over to Teddy's and spend like $30 on 2 tacos or something. You guys know what I mean? 3 tacos, $30. Like, what? Oh, jeez. Then I got to add salt and red onions when I get home. All right. Should we do a voting question? Anyway, voting. Give you guys an example. All right. We'll do a red onion question. Red onions, food. A sample of 150 college students reveal that 48 prefer pickled red onions on tacos. Okay. Then they're going to say this. Use the 95% confidence level to estimate the true proportion of college students who prefer pickled red onions on tacos. All right. This is a real life what? Estimation question. Real life estimation question. So now we're going to dive a little bit deeper. And darn it. Wow. Now we're going to dive deeper. We've got to go to my website now. And I'm going to go to my notes here. I think I have. And we're on estimation in the notes. There we go. I've given that to you guys. But we're going to actually share with you guys what you need to do here for this. And let me go through some details. Okay. So, all right, where are we at? No. We talked about this. We set the table. Oh, there we go. Here's what we're going to have to do. Okay? All right. So I want you guys to understand one thing when you read through this. I want you guys to say, okay, a sample of what? 150. You know what that is already. Your sample size is what? 150. Reveals that what? 48. That's successes. Prefer pickled red onions on their tacos. Just like me. So what I'm going to say to you guys is write down that information. Write this down. Write down your sample. Gave you what? The sample size is 150. And then how many successes did you have? X is what? 48. Okay, you guys okay with that? This is what you're reading. Okay. So it says use. Now you say, what are they telling me now? Use the what? 95% confidence level? What? I've never seen that phrase before. Okay. To estimate the what? See this? The true proportion of college students who prefer pickled red onions on their tacos? What's the true proportion, by the way? That's P. That's not a sample proportion. That's a true proportion. Okay, so I have to estimate the true proportion. You guys know what you do automatically? Do what I gave you guys last time. You're going to write down the format here. Okay. See that there? This is the format. This is what you're looking for. P. Now. All right. Mm-hmm. All right, so now what I'm going to have to share with you guys is a couple of things here, some knowledge here. If I go back to my browser here, remember the old days here? In the old days, ladies and gentlemen, we had this margin of error formula that you guys are looking at. So in the old days, I had to tell students, hey, compute the margin of error, E. And then they had to use the Z distribution. And yes, this is the confidence level information here, so you guys know. And you had to find these Z values here. Okay? In the old days. Anybody remember the old days? You took this class in high school, you had to compute a margin of error, then you had to use the Z table, and you had like 99% confidence level, 95% confidence, and 99% confidence. I gave you a 95% confidence. So in the old days, you had to find a Z value associated with a 95% confidence. And you said, how did I find the Z value? Well, in the old days, you had to use the what? The Z table in the old days. So this is what we learned in the old days, a Z table. And so you had to compute a margin of error. You know what you get to do now, ladies and gentlemen? In fact, this is an example that we'll go through, not right now. Today, what do you guys get to use? The TI calculator. Okay? And in fact, in the TI, I'm going to write it down in the iPad. What's the function in the TI? The TI says go to stat test. Okay. And then you use what's called one proportion what? Z interval. And you need to know the number of successes, the number of observations, and the confidence level. And that's it. All right? That's all you need to know. We're going to go through it, okay? I'm going to share that with you guys now. This is like amazing, I think. Okay? So, what did we not write down? What's the confidence level? What confidence level did they tell you? Put CL is what? 95%. How do you know the confidence level is 95%? Because they told you. They said 95%. What's 95% as a decimal? 0.95. You guys with me on this? You guys okay with that? So now, to answer this question, we just have to do what? Go to what? Go to stat, test, one proportion Z interval. One proportion Z interval. So I'm going to go to the TI now. You guys ready? So we're going to look for what? I'm going to clear this out. We got to go to stat. Where's stat at? I'm going to zoom in. Here we go. You go to what? Stat. And then you scroll over to test. And you scroll down to one proportion what? Z test, because you don't have to use the Z table anymore. Sorry, not Z test, Z interval. One proportion Z interval. It's down here. There we go. A. One proportion Z interval. Z interval, one proportion. What is X, ladies and gentlemen? How many successes were there in your sample? 48. What's the sample size? 150. What's the confidence level? 95. Okay. It was already set to 95. Now hit what? Enter. Look very careful. What do you guys see there? Say, Mr. Judge, I see the answer. Below 1 proportion z interval, give me that first decimal to the nearest thousandths. Isn't that 0.2 what? 45? Is that true? What's the next decimal to the nearest thousandths? 0.39 what? 5. Good. Do you guys know you're looking at an interval? That's interval notation. Parentheses, comma. You got a lower value and you have a what? Upper value. You want to know what that is? That's your lower value right here. That's this. And the green is the what? Upper value right here. So the true proportion, ladies and gentlemen, just so you guys know, is between, this is a true proportion P. It's between 24.5%. That's a percentage. And 39.5%. This is called an interval estimate. Okay? So now instead of a point estimate, you have an interval estimate. Also, aka a confidence interval estimate. So P is your true proportion, and it's between what? Those two numbers. And that is all you have to do in the TI, where in the past, you had to compute a what? Margin of error, okay, and use the Z table. And here's your margin of error formula right here, and plugged it in your format. Now, you just put your successes, you just put your sample size, and the confidence level. That's it. What do you guys think? Is that easy? I don't know. Why do people miss it then? In the old days, people got it. They go, okay, but they had to go through all of this in the old days. They went through more process in the old days, I guess. I don't know. Fast food order accuracy. You guys want to try this one? Let's try this one. Let's see what we get. Okay. Fast food order accuracy. Here's what I'm going to do. I think, what is this, estimation? You know what I'm going to do? Yeah, I want to go to DD Judge. Come on. Okay, I'm going to have you guys look at the browser. I'm going to try to download this here. If I have to log on. All right, school Wi-Fi. I'm not connected. All right, get me in the connection. Let's get connected. Even though down here we don't get anything. Okay, we are on 227. So I'm going to try to import this here into Notability so that you guys can see, and I can just highlight what's there. Estimation, and it's taking some time. There, nope, it's not there yet. It's taking time. Okay. Notability. All right. Okay. All right, you guys. So here's the deal. I'm gonna go all the way to the Mickey D's example. No, not medical lawsuits. Fast food order accuracy. Okay, we are in the iPad. Okay, let's see what it says. What do you guys think? It's saying what? In a study of fast food order accuracy, Mickey D's had 28 orders that were not accurate out of 402 orders. Hey, what happened? Okay, you guys okay with this? All right, notice what they gave us. This is a study. So what does that mean? It came from a what? Sample. Is that true? All right. Sample. What else did they say? 28 orders were what? Not accurate out of what? 402 orders. What does that mean, ladies and gentlemen? What's the number of successes? Be careful. What does X equal? What does N equal? Be careful. What is X? 28. There were 28 orders who were what? Not accurate. Is that right? Believe it or not, you say, is that a success? Yeah, that's a success. They're counting non-accurate orders. Out of how many? 402. And then what do they say? Use the what? 99% confidence level. Okay, use the, what's the confidence level? You guys know, how do you write 99% as a decimal? 0.99. To estimate, what are you guys estimating now? The true proportion of orders that are not accurate. So I'm going to have a lower bound value and an upper bound because this is going to be an interval estimate. Yes, it came from this format. Back in the day, you had to compute the margin of error. Now, what do we get to do? We get to go and use the what? TI. Okay, you guys ready for the TI now? Okay, scroll out. How do we use the TI now? Go to what? Stat. Tests. 1 proportion Z interval. It was A. 1 proportion Z interval. Hit enter. And how many successes? 28. Out of how many orders? 402. What was the confidence level in this example? 99%. So you put 0.99. Hit calculate, ladies and gentlemen. And guess what? There's your answer. Go to the nearest tenths. What is it? 0.03 what? 7. That's the lower value. What's the upper value? 0.10 what? 2. Okay? So I want you guys to notice this. This is the lower value in the interval estimate. This is the upper value. What is that as a decimal? That's going to be what? 3.7%, 10.2. So the real proportion is somewhere between what? 3.7% and 10.2%. That's the real proportion of fast food orders that are what? Not accurate based on a sample. I'm going to ask you guys to note what was the sample proportion, because it didn't give you that, did it? I wonder. Let's go to the TI. You know what this TI says? The TI is even giving you the what? The sample proportion. What's the sample proportion? 0.06. It's actually 0.0 what? 7. If I go to the thousands, right? Isn't the 9 in the what? Thousands position, digit to the right to 6, add 1 to 69, you get 7. Let me share with you guys something here. What if you said, I don't want to do that? I'd rather take my what? How many successes? 28 divided by 402. Isn't that the same answer? Do you see what I'm saying? So we even have the sample proportion, which is 7%. So the sample proportion is 7%, but the true proportion is between these two values. Okay, one is an interval estimate, the other is called a point estimate. And that's it for estimation for a proportion. That's it, Mr. Judge? I just have to enter three numbers in? Yep. You just have to know what the sample size is, what the success is, what's the confidence level. And you don't have to go through and use that old formula, and you don't have to use the table, and you guys are what? That's it. What do you guys think? Should we look at medical malpractice? Any business majors in the room? You might be interested in medical malpractice. What does it say? A study of what? A study is a sample. 1,300 randomly selected medical malpractice lawsuits. 835 were dropped or dismissed. Okay. Construct a what? 95% confidence interval, estimating the what? The true proportion of lawsuits that are dropped or dismissed. Sample information. Sample size is 1,300. How many successes were there? 835. 835 were dropped or dismissed lawsuits. What's the confidence level? Okay, how do we write 95? Isn't that 0.95? What are we estimating? The true proportion? I will still always write down the format, ladies and gentlemen. And let's go through and use the TI. Okay, TI, you ready? Stat, test. Scroll down to what? What do you guys scroll down to? 1 proportion Z interval. What do you enter for X? 835. What's the sample size? 1,300. What's the confidence level? 95. Hit what? Calculate, and what do you get? Ladies and gentlemen, you get all the information you need. What is this telling you? What's the lower bound value to the nearest thousands? 0.61 what? 6, less than P, less than, what's the upper bound value? 668. What's the sample proportion there? 0.64 what? 2. Okay, you guys with me on this? Take a look. Lower bound. Upper bound. This is where the true proportion is. What is this as percentages? Isn't that 64.2%? And what's this? 61.6 and 66 point what? 8. Ladies and gentlemen, there you go. This is all the information. That's what they're going to ask you for. The first one is a confidence interval. The second one is a sample proportion. So the true proportion P lives between those two values. You got a lower bound value, you got an upper bound value. That's where the true proportion lives. And that's with 95% what? Confidence. What do you guys think? Is that simple? When do you guys want to do your homework, by the way? ASAP. Right? Anybody learn that lesson yet? Some people know. They go, "No, Mr. Judge, I don't have enough pressure on me yet. I don't feel the pressure yet. I do better under pressure." I was like, really? Man. Pressure. That's like, imagine if you're going to enter a dance contest and the night before the contest, you start to learn how to dance because you don't feel the pressure yet. Anybody know what I'm talking about? Anybody here who knows how to dance? One person? Were you born knowing how to dance? You had to practice? Yeah, exactly. What do you dance? Okay. Takes practice. Anybody here salsa dance? Besides salsa's, yeah, I actually took lessons. You don't, yeah. It's a whole thing, ladies and gentlemen. In case you guys don't know, salsa dancing is a whole thing. Am I right? People don't know. You can't just go there and do it. And if you're a lady salsa, any lady salsa, what do you have to do? You got to follow the man. The man's in control in salsa dancing. You ladies have to respond to him. It's a very intimate dance, ladies and gentlemen. There's a lot to it. You think it's just dancing. No, it's a whole mindset. There's a whole thing. And there's a lot of people that like salsa. Dancing. It's not just what you put on your taco. Salsa dance. You guys know? Go out. You know where I used to go to? Forget. Don't even go there. I was so embarrassed. So intimidating. Alhambra, do they still do it out there in Alhambra at that dance studio? It used to be across the street from that burger place that closed down. Rick's in Alhambra. Rick's was a place. Rick's Burgers? It was across the street from Rick's, I think. I think it is. Was it? Maybe I'm wrong. Oh, really? Smoking, ladies and gentlemen, in case you're interested in stop smoking. In a program designed to help people stop smoking, 200 patients were given sustained care, with 85.5% were no longer smoking and were biochemically confirmed. Ooh, they just did something to you guys on this one. Use the 90% confidence interval to estimate the true proportion of people who receive sustained care who will stop smoking. So this is like a clinical study in how many patients? This is real life stuff. You go, Mr. Judge, I don't want real life anymore. Give me the ghost questions. So in this study, 200 people were given what? Sustained care, whatever that is. I don't know what sustained care is. And what did they tell you now? 85.5% were no longer smoking. They biochemically confirmed it. So I guess you can't lie because they checked you biologically. You can't say, I don't smoke anymore. No, we're going to check. You guys see what I'm saying? This is kind of what's going on in that question. And then they say, use the what? What's your confidence level? 90%. Okay, you guys with me on that? And they want you to do what? To estimate the true what? Proportion of people who receive sustained care who will stop smoking. So this is just based on a sample. Now, some of you guys are going to say to me, Mr. Judge, what's my X value? I can't use my TI. Well, do you guys know what X is? Let me remind you. Isn't the sample proportion X over N? Do you guys know what you could do? You could use a little bit of algebra. What do I mean by that? You can multiply both sides by what? By N. And what does that mean? X equals N times what? That's what you're going to have to do to get X. What is N here? Isn't N 200? What's the sample proportion as a decimal? It's point what? 855. You got to use a decimal representation. This is going to give me the X you need for the TI calculator. So sometimes they give you the sample proportion. They gave it to you right here. They didn't give you the number of successes. How do you know it's a sample proportion? What do you guys see? You see the percentage. That's how you know. Okay. So then how many successes do we have? Let's see. I'm going to go to the TI, scroll out. Okay. We'll hit clear. We say, okay, 200 times the 0.855, and that gives you now what? Oh, 171 successes. Good. I can now use the what? The TI, ladies and gentlemen, because I know how many successes I have. 171. Okay, TI. Here we go. Stat test. What do we scroll down to after stat test? 1 proportion Z interval. Okay, what was X? 171. What was our sample size? 200. Now they want the 90%, so it's 0.90. And ladies and gentlemen, just enter 3 numbers, and guess what? You get everything you need. Look at that. So what is the interval estimate to the nearest thousands? 0.81 what? 4 less than P less than point what? 896. What is your sample proportion going to be also? 855, ladies and gentlemen. So take a look. I just copied everything down and want to remind you guys, the lower value in the interval estimate, the upper value, and this represents here the sample proportion. So the true proportion is between 81.4%, 89.6%, where the sample proportion was 85.5%. And true proportion is P. So you gave an estimate on the true proportion, lower value, upper value, of people who will benefit from sustained care, whatever that care is. Maybe they gave you a, I don't know, whatever that treatment was. Yes. Yeah. Yeah, it's a sample proportion, but their symbol's a little different. It's like P with a little cap on it. But yes, that's a sample proportion. And that should make some sense, because why? They gave us the sample proportion 85.5%. So that makes a lot of sense. So what I'm going to say to you guys is, let's take a look. It makes sense. There it is. If I go to the browser now, Okay, this is really starting homework on estimation. Going to the browser. And that statistics lecture, what? I think it's 13. See that here? So statistics lecture 13. So I'm going to have to go through some of this. I'll give you all the homework now. What is that here?